myself Shammi and my colleague is Shilpa Seminar. We are presenting a seminar on the topic of automated engine control system. Uh, in this, we are explaining evolution of the engines and what is the ESC, that is engine control system, and engines, that is 4-stroke, 2-stroke, ECU, that is we are explaining operation and sensor used in the ECU, hybrid engine, and the brief comparison between hybrid engine and mechanical engine and ECU based engine. And finally, we are explaining about the applications of application where we are using the engines. First, we are going into the evolution of the engines. The first engine is developed by Etienne Leonard of France in 1860. It is he developed the steam engine, which is which works on the steam. It is the mechanical engine. It works on the steam as a fuel, and after that, later, after some research on that steam engine, in 1903, the gasoline engine are developed. After within that period, before 1903, the hybrid engine was built, but it cannot be used till 100 years. After in 1999, the company Honda developed the first hybrid car using the hybrid engine, and the first diesel engine is developed by Rutherford Diesel. That is the inventor of diesel engine, and the first four-cylindrical vertical engine is developed in the starting of 1906. That is gasoline engine, but which contains the four-cylindrical vertical engines. Then comes to the next slides. What is engine control system? Engine control system is the type of electronic and mechanical control unit that controls the series of actuators on an internal combustion engine to ensure the optimum running with more efficiency. Before going to explain the automotive diesel and petrol engine, I want to explain the gasoline engine and the steam engine, how they are working. First, we are I'm going to explain the steam engine, which is work on the which take the fuel as a steam, and it will work on the phenomena of the external combustion of the fuel. And next one is the gasoline engine, which is work on the internal combustion, which is work on the phenomena of the internal combustion engine, in which we are using the volatile fuel and electrical spark for producing the energy to movement or the starting of the engines. Then come to the automotive diesel and petrol engine. The main advantage of the diesel and petrol engine over a gasoline engine is their good fuel efficiency. Diesel and petrol powered automobiles average about 25% more miles per gallon than gasoline powered automobile. Diesel and petrol engine, however, must be made larger, stronger and heavier than gasoline engine. As we see, the diesel and petrol engines are heavier than the gasoline engine. Gasoline engine comes somewhat smaller as compared to diesel and petrol engine. They must withstand combustion pressure 2 to 3 times higher than those produced in gasoline engines. Next, I'm going to explain what are the types of diesel and petrol engine. As we know, main type of the engines are four-stroke cycle engine and two-stroke cycle engine. This engine differ in the number of piston stroke required to produce the power strokes inside the engines. This is the four-stroke cycle engine which produce the energy, which provide the energy uh, with the ignition the fuel inside the cylindrical chamber. Here in this diagram, uh, uh, we are I am going to explain the working of the four-stroke engine. In this, the main in the four-stroke engine is the main part is the intake valve and the exhaust valve. And this in a four-stroke cycle engine, it will the piston rotate 4 times per cycle inside the cylindrical chamber. The in the first cycle, that is we call as the intake cycle. That is when we are going when the pistons rotate to its first rotation, the intake valve is open and fuel is came inside the cylinder, and in second cycle is the compression compression cycle. In that the intake valve is closed and the fuel is get inside the chamber of the cylinder. And in the every third cycle of the four-stroke engine, there is one fuel injector is there, with which we are igniting the electric spark to get the to burn the fuel inside the chamber. And in third stroke, we are getting the exhaust. The gas inside the cylinder is exhaust through the exhaust valve. Let's go to the next slide, which shows the two-stroke cycle engine, how it works. In a two-stroke cycle engine, we are getting only two strokes per cycle, in which in every second cycle of the stroke, we are getting ignition inside the chamber. In the first cycle, as we see in the slides, that in first cycle the fuel gets inside the chamber, and in the second cycle the fuel gets ignited, and the fuel that intake valve is closed and the exhaust valve is open for the exhaust that gas inside the chamber, and prepare it for the next cycle. And the next part is explained by the Shilpa.
Coming to the electronic control system, there is it mainly consists of sensors. There are different types of sensors like input sensors and oxygen sensors, etc. One more it consists of electronic control unit. Electronic control unit is a main part in this system, and fuel injector assembly and relevant wiring. According to the connections and all, we need related wiring and fuel injector assemblies for processing injector we need. And the ECU determines mainly engine control unit determines how much fuel needs to be delivered to the injector based on the engine sensor's output. When the injector is turned on, its precious amount of air fuel ratio is delivered to the engine. And this is the engine control unit system. You can see the different types of sensors like input sensors and NOx sensors, and intake air temperature sensors, and throttle position sensors. Basic operation of engine control system: when the air enters in the engine, inside the engine there is a airflow meter. The air is measured by airflow meter, and as air flows into the cylinder, fuel is mixed into the air by injector. Engine control unit pulses the injector. When the injector is on, there is a switch on and off. When it on, there is air fuel ratio is enough. When the injection is on, there will be fuel occurs to the ideal fuel ratio is 14.7:1, and the engine control unit delivers